bacteria, chlorine, and lead contaminants and things of that nature. So there's a barrage of tests that you could test personally yourself. Now, I picked this up directly, obviously, to test the validity directly of the water. Also, the pH content. The pH is very important. The higher the pH, okay, the lower the acidity directly of the water. Now, it's been shown that people that drink highly acidic items like alcohol, things like soda pop and things of that nature, essentially what happens is that you become prone directly to certain disease disorders, and science has already been clearly showing this. So what this is showing is that we can actually show with this test that we have a pH balance of over a 7 to 8 point acidity level, or alkalinity level in this case. If it's below 7.0, it's preferably a acidic water, and that's something that you don't want to drink. Internally, the higher the pH at a certain ratio, you don't want to have too high of a pH, obviously, and you don't want to have a low pH, obviously. You want to have something in between. It's all a balance. So that's where I got this test kit from. You can pick it up at Granger. I'm not making this up. This is actually a part of the testing procedure that we have. All that tests that I just mentioned about, for the contaminants, that's all in there. And we have the test strips to actually prove that. And what I'm going to do is I'm going to see if I can actually go for these test strips, and I'm going to see if I can find these test strips that I mentioned about. And I put them in my bag, and I hope to goodness that I can actually find them. Just give me 1 second here. I'm going to put this down just for a moment. I don't know if you're able to... okay, hold on. One sec. See where we're at here. Okay, hold on. Okay. All right. This is one of the test strips over here. I don't know if you can see this. I'm going to put it down here. All right. Now I'm going to open this package up over here, and what I'm going to do is I'm going to show you there's a chart. Now what we did is that there was water that actually was taken out of this system from the water over here that we've actually accomplished on filtering. And there is a chart that's over here in the test kit, which actually clearly shows the viability of the test. And I'm going to move my finger out here so you can see this. All right, so we have here. Now, this is the test kit that we've actually looked at. Now, again, we were looking at pH, nitrates, and so forth, and that's one of the tests over here. The other one would be the alkalinity test. Okay, so I'm going to put this over here. You have acidity, alkalinity, and that also tells you about hardness and so forth. Okay. We have a system directly that is close directly what we're asking to achieve, which is actually approximately 6.5 to 7 to 8 pH balance. And pH stands for parts per hydrogen, by the way. So what's interesting about this test here is that we were able clearly to show that we can get 7 to 8% or 7 to 8 pH directly with this test kit, which is a significant thing because of the simple fact that if you look directly at the water which is coming out of here, as opposed to what the separation process is, we're taking water and we're working with an implosion process by spinning the water at a certain speed. And that speed actually creates a vortex or implosion type system, which is inside this device that you see here. That water is then separated, the contaminants go on the bottom like I mentioned before, as well as the fresh water going on the top, and that's separated accordingly. Now, obviously I can take both systems over here and I can combine them into one, and I can just have one pipe come out, and I can actually improve the quality of someone's water directly in a household, a school. I can clearly show that. There's other technologies that we're going to be adding on with this technology that you see here. This is a preliminary test, and again, this is the Implosion Water Test 1.0. How can we make clean water? Thank you.